Hello, my dear students. I know, the exams are so close. So let's get ready for a super quick power-up revision, okay? The Biomolecules chapter. Is it giving you a little tension? Seeing all those structures and names can be a bit scary, right? Added tension mat lo, don't worry at all, bacho. Your loving tutor is right here, and believe me, we are going to master it together. We'll turn this chapter into a story about an incredible team of superheroes living inside you. Ready? Let's go. All right. First up, let's meet Team Carbohydrates. These guys are the instant energy heroes. Think of them like the sprinters on a racetrack. They give you that super quick burst of power. You know that glucon-D you drink before playing cricket? Yup, that's a carbohydrate in action. So what exactly are they? Well, the name itself gives a clue. Carbohydrates. They are basically made of carbon, hydrogen, and oxygen. And their main job? They're the petrol for our body's engine. They're the main fuel that keeps us going all day long. Now, this part can look a little complex, I know. But just imagine you're a detective solving a mystery. The mystery of what does glucose look like? Scientists found clues one by one. Clue number 1. They reacted it with HI, and poof, they knew it was a straight chain of 6 carbons, like 6 bogies of a train. Clue number 2. They used bromine water, and that proved there's an aldehyde group at the top. Then clue number 3. Acetylation showed it has 5, count them, 5 OH groups. And the final piece of the puzzle? Oxidation proved there's a primary alcohol group at the very end. See? It wasn't magic. It was just brilliant detective work. But wait, there's a twist in the tale. That straight chain, well, glucose doesn't really like staying like that. It's a bit unstable. So what does it do? It's very smart. It curls up on itself and forms a nice, stable ring, a cyclic structure. And this ring form, it's so important for everything it does inside us. Okay, everyone, listen up. Exam alert. This is a pet question for the examiners, a classic 2-mark question that you will very, very likely see. Why is sucrose called invert sugar? And here is the perfect, simple answer you need to write. See, sucrose, that's our normal table sugar, is dextrorotatory. That's a fancy word that means it turns light to the right, in the positive direction. But when you break it down with water, that's called hydrolysis, you get 2 things, glucose, which is also dextro, and fructose, which is strongly levorotatory. It turns light way to the left. So the final mixture actually turns light to the left, to the negative side. The rotation literally inverts from plus to minus. That's it. Easy marks. Okay, next team up, meet the proteins. If carbs were the fuel, then proteins are the body's master builders. They are the bricks, the cement, the steel rods. They build everything. Your muscles, your hair, your skin, the enzymes doing all the work, it's all protein. So, what are these amazing builders made of? They're made from small units called amino acids. And here's the key thing to remember about them. Every single amino acid has 2 special groups. An amino group, the NH2 part, and a carboxyl group, the COOH part. Both are always there. Even their name tells you they're a big deal. The word protein comes from a Greek word, proteos, which means of prime importance, or number 1. And honestly, they truly are that important. Okay, another one of those favorite exam questions. What is a Zwitterion? The name sounds a bit strange, I know, but the idea is actually super simple. So a Zwitterion is just a neutral molecule, but here's the catch. It has a positive charge and a negative charge on it at the same time. How? Well, inside the amino acid, the hydrogen from the acidic COOH group just hops over to the basic NH2 group, so you end up with COO- and NH3+, a plus and a minus on the same molecule. And guess what? This is exactly how amino acids hang out inside our bodies. Now, proteins aren't just long, boring strings. They have amazing 3D shapes. There are 4 levels to the structure. Think of it this way. Level 1, primary, is just the simple sequence of amino acids, like beads on a string, one after another. Level 2, secondary, is when that string starts to coil up like a spring. We call that an alpha helix, or it folds back and forth like a paper fan, which we call a beta-pleated sheet. Then comes tertiary, level 3. That's when the whole spring or fan folds up even more into a compact 3D ball or fiber shape. And finally, quaternary. That's the grand finale, where multiple folded chains come together to form one giant working protein. And look at this. This is the perfect example of that fourth level, the quaternary structure. This is hemoglobin, the superstar protein in your blood that carries oxygen. You see those different colored chains? That's 4 different polypeptide chains all packed together, working as one single team. And this exact perfect shape is what lets it grab oxygen in your lungs and deliver it all over your body. If the shape was even a little bit wrong, it wouldn't work. Isn't that just mind-blowing? Okay, time to meet the sidekicks of our superhero story, the vitamins. They are tiny, yes, but oh so mighty. They don't give you energy like carbs or build your body like proteins, but without them, our main superheroes just can't do their job properly. They're the essential support team. Now we can divide vitamins into 2 main groups, and it's very simple. It's all about where they dissolve. First, we have the fat-soluble team, vitamins A, D, E, and K. They dissolve in fat, which means our body can store them for later. Then we have the water-soluble team. That's the B group and vitamin C. They dissolve in water, so our body can't store them. Whatever we don't use gets flushed out. That's why you need to have them in your diet every single day.
Okay, bachon, screenshot this, write it down, do whatever you need to do, but this table is gold for your exam. You must memorize it. Vitamin A from carrots for good eyesight, otherwise you get night blindness. Vitamin C from amla and citrus fruits to stop scurvy, that's bleeding gums. Vitamin D from sunlight for strong bones to avoid rickets, and B12 super important for your blood to prevent anemia. This table is basically free marks, okay?
And finally, we come to the masterminds of the whole operation, the secret keepers of life's code. Our last superheroes, the nucleic acids. These guys hold the master blueprint, the entire instruction manual that tells your body how to build and run itself. Everything starts here. The 2 big players on this team are DNA and RNA. So what's the difference between them? It's easy, just 3 main points. First, the sugar is different. DNA has deoxyribose sugar, RNA has ribose sugar. Second, one of the bases is different. DNA uses T, thymine, while RNA uses U, uracil, instead. And third, their structure. DNA is that famous double helix, 2 strands twisted together. RNA is just a single strand. Think of it like this. DNA is the master blueprint safely locked away in the head office. RNA is the messenger who makes a photocopy of one part of the plan and takes it to the workers on the factory floor. Just look at this beautiful structure, the famous double helix. It looks like a twisted ladder, doesn't it? Or, for us, it looks a bit like a jalebi. And the most important rule, the golden rule you have to remember, is about the steps of this ladder. A will always pair with T, and G will always pair with C. AT, GC. That's it. This perfect pairing is the secret to how it stores all our information. All right, so we've met the entire superhero squad. Now, for the final lap, let's do a super fast revision to power up for that exam. So let's quickly recap our superhero team. Carbohydrates, they're for instant energy. Proteins, they're our bodybuilders. Vitamins, the tiny but essential helpers. And nucleic acids, they are life's master blueprint. Got it? Simple. So there you have it, the whole team. Now you know all the superheroes. So I'll leave you with a little food for thought. Which one of these biomolecule superheroes do you think is the most important for life? And why? Think about it. There's no wrong answer here. You guys have got this. All the very best for your exams, Bacho. You are going to be fantastic.